In the last video, we mentioned that IRR is generally consistent with NPV. So when we have a single normal project, NPV will be greater than 0 when the IRR is greater than the cost of capital, and NPV will be negative when the IRR is lower than the cost of capital. So in that sense, NPV criteria and IRR criteria can be quite consistent. However, problems can occur if cash flows are not normal, and there will also be problems when we have to choose among mutually exclusive projects. So to explain these two things we just mentioned here, we look at the so-called NPV profiles. The NPV profile is a graph of NPV with different discount rates, and it helps us if we may enter a problem with IRR. If we enter cash flows in our financial calculator to find NPV of a project at different discount rate, of course we come up with different NPV results. These results can be captured in a graph called NPV profile, such like this. For normal cash flows, or say for a project with normal cash flows, the NPV profile generally slopes downward, and that means NPV goes down, or say goes lower, when the cost of capital rises. The more expensive the cost of capital is, the lower NPV you end up with. IRR can be found while the profile crosses the x-axis, so it's here. According to the definition of IRR, IRR is the discount rate that makes NPV 0, right? So here, about 20%, this is the NPV of this project in figure 13.1. Now, for non-normal cash flows, there will be multiple IRRs for the same project. So for example, if we look at this non-normal project, we have a negative cash flow at the beginning, and positive cash flows, and then negative, and then positive, and then negative. So that's a typical non-normal cash flow project. So then, why do I say they would have multiple IRRs? Because mathematically, IRRs represent to the solution to a mathematical series, and these solutions are called roots, and the series will have as many roots as there are sign changes. So in this case, you have 3 changes of sign, and that indicates you can have more than one solutions that makes the NPV 0. So for us, that means there will be many IRRs as there are sign changes in the cash flows. So for example, this is a sample NPV profile for a project with non-normal cash flows, and the line crosses the x-axis twice. That means this project has 2 IRRs. So one is here, and then the other one is here. Having 2 IRRs for one project can be a little bit confusing, although mathematically both are the correct answers, or say the correct solutions that makes the NPV of the project 0. So we can fix the problem of multiple IRRs using a technique called modified IRR, but modified IRR calculation is not required for this class. So at this point, let's just keep in mind that it is possible for a non-normal project to have multiple IRRs, and that makes the decision process based on IRR a little bit difficult or confusing. Let's also look at the IRR for mutually exclusive projects. Remember that for mutually exclusive projects, we can only accept one, and if we accept one, we have to give up the others, and we cannot take both projects. So what makes 2 or more projects mutually exclusive? Generally, mutually exclusive projects either share a common assets or target a common market, but the company only has resource for one of them, or the market can only accept one product. So that's the rationale for only accepting one proposal or one project and then rejecting the others. Of course, then the idea is we want the best out of all the proposals, but then the question is, how do we know which one is the best? If we look at table 13.9, we have 2 projects, project A and B here, and we have the timeline for each project and the cash flows. And we can calculate the NPV of both projects under different level of cost of capital, and the results can be captured in the NPV profile. So we put 2 NPV profiles in this one same figure for both project A and project B. So apparently project A is the one with the yellow curve and project B is the one with the blue curve. You can see from figure 13.3 the IRR of A is 32.88%, so that's IRR of A. And then for IRR of B is about 40%, so IRR of B is about 40.59%. And also the two NPV profiles somehow cross each other. So let's see, this is when they cross each other. First, let's suppose the project have a 30% cost of capital, so that's pretty high cost. Then the NPV for project A would be 29.47 and the NPV for project B would be 68.88. So let's see, when the cost of capital is 30%, we can look it up, and for project A, this is the NPV for project A, and then for project B, this is about the NPV for project B. So that means project B has a higher NPV, and according to the NPV decision criteria, we would choose project B and give up project A. If we use IRR in the same situation, project B's IRR 40.59% and project A's IRR is 32.88%, so no doubt project B has a higher IRR. So according to the IRR rule, we also accept project B. Now let's see what happens if the cost of capital is only 10%. So what if the company actually can manage to raise capital in a not so expensive way? So when the cost of capital is about 10%, this is project B's NPV, and it's around here. And this is project A's NPV, and it's around here. So one is below 300, one is above 300, right? So NPV for project A will be 312.91, NPV for project B will be 276.63. That means project A now has a higher NPV, and then according to the NPV criteria, we should accept project A and give up project B. But now if we use IRR without is not affected by the cost of capital you are using. So IRR of B is still 40.59% and IRR of A is still 32.88%. So B still has a higher IRR than the IRR of A. And so if we follow the IRR rule, we would still have to choose B. So now we have a summary of what we run into. If cost of capital is 30%, according to the NPV rule, we choose B. According to the IRR rule, we also choose B. But if the cost of capital is 10%, according to the NPV rule, we choose A, and according to the IRR rule, we choose B. So now it looks like we are in a difficult situation. So what's the verdict? What should we do? Generally, we say the NPV statistic includes the cost of capital in its calculation. So when we get to the runoff, we can make an interest rate cognizant decision. And IRR does not incorporate the cost of capital. Therefore, we will always be comparing the same two IRRs for two particular projects, no matter what the actual cost of capital is. And as we mentioned before, NPV and IRR are based on different reinvestment rate assumptions. NPV assumes that future cash flows are reinvested at the WACC, which is the weighted average cost of capital. And IRR assumes that the future cash flows are reinvested IRR. We have to say that reinvest at the WACC is more realistic than assuming that the future cash flows can be reinvested at the IRR. So the NPV method is a little bit more reasonable. Therefore, NPV should be used to choose between mutually exclusive projects. So the general conclusion is it is more reasonable to choose the NPV with higher NPV according to the actual cost of capital the company is facing. And of course, in reality, in practice, there are many other concerns, but general principle here is that it's more reasonable to choose a project with higher NPV. The last technique we just want to mention here is the probability index. Probability index is calculated based on NPV. So you simply use NPV divided by the initial amount of investment, or say cash flow at time 0. So this is a measure about pound per buck invested. Say out of $1 investment, how much NPV can be earned by the project. So since probability index is based on NPV result, to be consistent with the NPV benchmark, the probability index benchmark is also the accept the project if the probability index is positive or greater than 0, and you want to reject the project if the probability index is lower than 0 or say negative. So again, this is quite consistent with the NPV decision criteria. If we are looking at the same project that we used before, we calculated NPV as 11 to 97. So now to calculate the probability index, we simply use the NPV divided by the amount of initial investment, which is $25,000. So now we have the probability index of 45% of 45.19%, and it's positive, so we should accept the project. So this is a very simple concept based on NPV, and it measures the NPV per dollar of initial investment. So in this lesson, we review the concept and calculations of several basic capital budgeting techniques, including payback, NPV, IRR, and PI. And there are some other techniques that we mentioned, but we didn't really go to the details for this class. So for example, for payback, we understand payback measures the number of years, or say measures time, and it does not use time value of money in its calculation. And the benchmark for payback can vary, it's quite arbitrary. And NPV measures dollars. There we compare NPV result with 0, and the calculation of course is based on time value of money. And the NPV criteria works pretty well with non-normal cash flows, and also works pretty well for choosing among projects, no matter whether they are independent or mutually exclusive. For IRR is an internal rate of return, so it's a percentage rate, and we want to compare IRR with the cost of capital. And the IRR calculation is also based on the time value of money. But IRR decision criteria doesn't really work very well with non-normal projects, and also when there are multiple mutually exclusive projects, if we rely on IRR, we may also run into problems. We did not really talk about this kind of payback or modified internal rate of return in detail, so they will not be required for your exam. Probability index is based on NPV, and but instead of calculating our NPV in dollar, now we standardize it into a rate. Consistent with NPV, we compare probability index with 0, and since it's based on NPV, and NPV calculation is based on time value of money concept, of course PI uses time value of money concept as well. The PI works pretty well with non-normal cash flows because NPV calculation works pretty well with non-normal cash flows. However, we need to be aware that while we can be pretty confident to compare NPVs when we have to choose among mutually exclusive projects, we may not be so confident when we look at the probability index, because probability index is NPV standardized by amount of initial investment. So some projects with very small investment can have a high PI, while the NPV is not really that high. So that's something we need to be careful about. We discussed limitation and weakness of some capital budgeting techniques. Also in this chapter, you should be able to describe what is a normal and what is a non-normal project, and when would projects be independent and when would projects mutually exclusive, and how would that affect our decision making.